this webinar. It's 9 o'clock here in San Diego, so we'll begin it. Today's webinar is the first in a series of 4 cheminformatics webinars, and today we're going to focus on chemical spreadsheets, shown here, and the molecular editor. In 2 weeks' time we'll have another webinar on chemical data analysis and searching, followed by chemical library enumeration, and then the final webinar in the series is looking at structure-activity relationship analysis. My name is Andrew Ori, so if you have any questions after the webinar, please feel free to email or call. During the webinar there is a question, there's a button on the right-hand panel of your display that you can click and you can write a question, or at the end you can raise your hand and I can open your mic and you can ask the question. Today's webinar will be recorded and you can view it on YouTube, and we'll also send you an email with the link if you want to look at it. And a 30-day ICM-Chemist license is available for all webinar participants. Hopefully most of you got to receive the email that I sent, and so a lot of you have the license already, so you can follow along. But feel free to we need the host ID of your machine and send it to me, or that online form, and I can send you a license key. So today's topics are, we're going to start by building how to bring in chemical information into an ICM chemical spreadsheet, and how to export chemical data to, for example, Excel sheets. And I'm going to show how to sketch chemical data, the different chemical spreadsheet display options, how to add properties such as molecular weight, log P, solubility, and other Lipinski rule type of properties, and other properties as well. And how to manipulate a spreadsheet, so you have to copy, paste, hide, rename chemical data, and then how to work with other kind of chemical formats such as smiles, InChiKeys, and 3D environment, and how to build your own chemical spreadsheet template. So if you're new to the field and you're wondering where you can access cheminformatics data or chemical data, here's just some examples online. So the biggest one is called the Zinc database, where with probably more than 35 million now chemicals on that database, where you can search and download chemicals in STF format. And Microsoft's ICM-Chemist understands STF format, which we'll see in a minute. Another example is the eMolecules database, which is a diverse set of chemicals which you could use, and you can then purchase them directly from eMolecules. And also Microsoft, we keep a database called Molcart, which we compile from around 35 different chemical vendors such as ChemDiv and Cambridge, and we compile their latest collection of purchasable chemicals into one file, and you can use that if you need it. There are other, obviously, web-based databases that you can search, and these are directly searchable in ICM-Chemist. So you can search the PubChem database by smiles or by text. You can search Chembl database, as well as the patent version of Chembl, SureChembl as well. And I'll show you how to do that in a minute. You can also search Drug Bank and metabolite database such as KEGG, and other ones such as Metlin and HMDB. You can download the SDF files from these and view them in ICM. But for example, for Drug Bank and Chembl and PubChem, you can directly search in the ICM environment. So we're going to start with an example of a set of compounds which are quite interesting. We're going to build our own small database. If you're following along, I'll try to go as slowly as possible, but you can always review the recording at the end. So we're going to look at some COX cyclooxygenase 2 inhibitors, and cyclooxygenase 2 is responsible for formation of prostanoids, and inhibiting COX-2 can provide relief from inflammation and pain. So The selective COX-2 inhibitors that we're going to look at are members of the non-steroidal anti-inflammatory drug class. And targeting selectivity for COX reduces the risk of peptic ulceration and is the main feature of certain drugs such as Celebrex, Vioxx and other drugs shown here. As you're probably aware, they're quite interesting due to the controversy surrounding some of them. After several COX-2 inhibiting drugs were approved for marketing, data from clinical trials revealed that some COX-2 inhibitors caused a significant increase in heart attacks and strokes. And back in 2004, the Vioxx was taken off the market, and other inhibitors in this class were given, or other drugs in this class were given black box warnings. So we're going to build our own set of COX-2 inhibitors to start with. So one way you can read in chemical data into ICM is to use a SMILES string. This is the SMILES string example here for the COX-2 inhibitor Bextra shown here. So you would either have an Excel sheet with many columns of these SMILES strings, or you can just take a single SMILES string and then copy and paste it into ICM, which I'll show in a minute, to load the structure of that drug. So SMILES is a specification in the form of a line notation for describing the structure of chemicals using ASCII strings. So common atoms are represented by element symbols. Other elements are shown in square brackets. Single bonds are not shown, but double bonds are shown like this, and triple bonds with a hash. And when you have a ring closure, they're separated by brackets. If you want to read more about the SMILES format, you can go to daylight.com and read more about it here. So we're going to make a small database of inhibitors. So I'm going to just copy this string as I suggested, and you could maybe get it from the web, or you have it separately on another software. In your desktop environment, you have this symbol, which is the ICM software. So you just need to double click on that, and it will load the display as shown. And then at the top, we have a number of different buttons. The one we're interested in using is the molecular editor, which is this one here. It has a ring and a pencil, so it's a sketcher basically. So we just click on that one. I've got a molecule in there already. But, so we need to paste this SMILES string. So we go to Edit. This opens up this window, which we'll show in a bit. But you can go to Edit, and you can say Add SMILES. And then you just paste the SMILES string, and it transfers it to a sketch shown here. And we're going to make a small database. So we're going to add this to a chemical spreadsheet. We're going to make a chemical spreadsheet. So all we've done is clicked here, and then we click on this button here, which appends the molecule to a chemical table. So one click on here displays this dialog box, and we can say give your table a name. And this is the Bextra. Just go OK. And you can see now, when you press OK, we have the first element of our chemical spreadsheet shown here. So if I go back to the slides, another useful way of inputting chemical data is to use the Inchi format. Inchi stands for IUPAC International Chemical Identifier. It's a text identifier for chemical substances. It provides a standard way and human-readable way to encode molecular information, and it's ideal for chemical search. So you can, in a similar way to the SMILES, you just select the text. So the Inchi, this is the Inchi key for the COX-2 inhibitor alkoxia, and then you can just paste it in the same way as we did with the SMILES string. Another way to input data is a common format is the mol format, and a collection of mol files in one single file is usually referred to as an SDF format. So basically in the SDF format it's very useful because you can have additional properties placed in this format and it saves it. So things like molecular weight, name, comments, and other information you can save in the SDF format, and you can read it into ICM. And if you read the SDF format into ICM, it immediately becomes a chemical spreadsheet, as shown here. So just to show you how to do that in ICM, to read in a mole file, we go to File and go Open, and I have a mole file. You might need to expand it to all. I have a mole file here called Celebrex, which is another COX-2 inhibitor. We just go Open, and you see as I opened it, it opens immediately into another chemical spreadsheet. So we have two tabs here. We have the original Bextra drug, and we have Celebrex. So if I double click on one of the tabs, it separates the two files, and I can just copy and paste. We just want one single file, so I'm going to copy and paste this by selecting it and right clicking on the row and say copy row, and then you can paste that row into our database here. And we could just edit the name to Celebrex. Okay. And I no longer need this table, so I can just right click on the tab and say delete, and then we have two molecules now in our COX-2 inhibitor database. So another way to import structures is to sketch them yourself. So as we saw when we used the molecular editor, you can go edit, paste the smiles, or you can use this window here, and we can sketch this molecule. So we go back to the ICM environment. The editor is this button here again, and we just click on that one, and that opens the chemical editor. We still got Bextra in our editor. I was going to select it, and you can just use delete, or there's an erase button shown here. And the next COX-2 inhibitor we're going to use is called Vioxx. And so it has a sulfonamide, it has a ring and a sulfonamide group. So you can use the templates here to sketch, and the templates here. So these are bonds, and you can use the keyboard. So for example, for nitrogen, you could click here, or you could just use the keyboard and type N. And if you double click on a single bond, it will turn it into a double bond. So I'm sketching here. So this is a sulfonamide, so this is sulfur, and then we have a bond here to nitrogen. And we have additional templates shown here. So it has a 5-membered ring and nitrogen. Another ring off here. There are other groups and things you can choose here. For example, complicated bicyclics. There's some inbuilt templates that you can use, and there's some other tools for other sketches. There's also templates here for amino acids, bases, rings here. So you just click here, or you can if you have a template that you use quite often, then and it's not included, you can add your own here that you can easily use. So I'm just going to use the center button to bring it down here, and this is our Vioxx molecule. And you can see as I was sketching, if I delete something, on the right hand side the property monitor automatically calculates the new property. So it's automatically calculating the formula, the smile string, the UPAC name, Inchi key, and the properties such as molecular weight, number of hydrogen bond acceptors, hydrogen bond donors, rotatable bonds, area, and other things. And it will also flag any potentially reactive groups that may not be ideal in a drug. and it also flags the groups that you're sketching, so it will label some regions. So as we did before, when we're happy with this sketch, we can give it a name. We can double click here and we can add a name and go OK, and then we can append it to a chemical table as we did before. So we click on this button here. It asks us where we want to put it. We could put it in a new table if you wanted to, but we're going to add it to our small database of COX-2 inhibitors. So go OK. So now we have 3 inhibitors in our small database. So to add another one, we are inbuilt into the editor. We have a chemical or drug dictionary. So you can see this. Hope you can see this button here. It's a dictionary, so you can type the name of your drug. Another COX-2 inhibitor is called Arcoxia. So I'm just going to start typing it, and it finds it. The drop-down button here, and we can just click on it, and it sketches it as before. We can double-click and give it a name again, and then add it to our spreadsheet. Okay. So we have four drugs. Just another way of bringing in chemical information I want to show is that you can also download a PDB file, for example, and extract the chemical from that. So we're going to move on to searching. So to search the PDB by text, you can type in a PDB code here, or a string, some search string. But we might be interested in finding all the protein structures in the protein data bank that contain the COX-2 inhibitor called indomethacin. So we can search the PDB by chemicals. So you can see that we have this little ring here in this search button. If we click on that, it brings up this dialog box. So if you knew the SMILE string for indomethacin, you could just type it in here or paste it in here and it will search, but I don't know it offhand, so I'm going to just sketch it. I'm going to go to the chemical dictionary again, type indomethacin, like that, and it sketches it. And then I close this window, so it asks me to save changes, and hopefully you can see that it's now placed the SMILE string in the search bar here. And then we can just press search, and it's quickly gone through the PDB and found all the structures that have indomethacin bound. So we can see the PDB code here for each one, and there's actually 23 structures which have indomethacin bound, and you can just double click and browse through these structures, so and it will take you directly to where the indomethacin is bound to the crystal structure here if you double click like this. Okay, but for this exercise we're not too interested in the 3D graphics. We're more interested in the chemical side of things. So I'm just going to go to Windows default layout, and that brings up the panel on the left hand side. We've got the structures here. You can see that we have indomethacin bound to this PDB called 4XUM. If we expand here, you see the molecule here. And I want to put this into our small database of COX-2 inhibitors. So I can extract it from the PDB, just right click and choose extract ligand. You can edit the compound and then place it into the PDB like that. So that's another way of bringing in chemical information into ICM. I'm just going to delete those objects. So we have the PDB search results that I just showed, but they're not too useful at the moment, so I'm just going to delete that table. Right click and say delete. And we have our small database of COX-2 inhibitors here. So another way to bring in information would be to download COX-2 inhibitors from other external databases. So if you go to the Search tab, we've just done it from the PDB, but you can also search drug bank, for example. You can sketch, as we did with the indomethacin, and you can search by chemical name, drug bank ID, SMILES, substructure, UniProt code for or protein family, and that will download the data. It's the same with PubChem. You have the similar. If you just use the click down button, you can use here. And also Chembl, which is a very useful database with the chemistry as well as the activity data included in the database. So that's Chembl, and sure Chembl has the patent information as well related to each chemical. So you can do a Chembl search. We could, for example, type cyclooxygenase 2 in the protein name, and that will search Chembl and will give us a data. It takes a minute or so to run, so I have an example. We're just going to open it and I'll show you the search results. So if you search Chembl, you will get a chemical spreadsheet similar to this one here. So it has. So we now have two spreadsheets. We have our smaller one and our larger one. And this is the search results from searching Chembl by text, by a string. And so we can see at the bottom, hopefully, you can see the statistics on the table. We have 5,713 chemicals that are annotated in Chembl as being COX-2, have activity to COX-2 in some way. And we also have 31 different columns. If you want to browse the table, one way would be to keep it in this spreadsheet view. Another convenient way to view the table is in grid view, and you can do that by selecting columns that you want to see. I want to see the molecular structure, so I click on the column. I click on another column, and I want to see the activity of this of these chemicals, and then we can just click on the right hand side. There's some buttons here. This is for a grid view, so here we just see the structure, the name, and some activity value that is reported in Chembl. Another convenient, if you want to go back to the spreadsheet view, there's a button here to go back to spreadsheet or table view, as we call it, shown here. Another convenient way to go through your data is to click on this button, which is a form view representation. So you can then toggle through the structures using the buttons here, and it has all the information in one panel shown here. There's chemical searching functions, which we're going to cover in 2 weeks' time in the next webinar. So you can search databases, and so you can scan through like this. I'm just going to go back to the spreadsheet view. So in the spreadsheet view, you can also sort your table. A single click on the table header, on the column header that you want to sort, enables sorting. So we've got some this is a molecular weight. It's sorted by molecular weight. You may also want to color columns, and you can color columns by the values that are contained within them. If you right click and you go down to the option Format, Color, Action, so you right click on the column header, you click here. Now you can change the font color in the column. You can make a rainbow, color it by the values. So I think the low molecular weight ones will see the color and you apply. You can see here it's colored according to this rainbow. So higher molecular weights will, at the bottom of the table, will have a red coloring. Green to red. And in that dialog box, you can also choose to add links. So you can make, for example, if this was a PDB code, you could link this text to a HTML format, and it can be fully interactive like that as well. Okay, so this is our chemical spreadsheet. We've added, you may want to add some additional properties. You see that in here, in this by default, in this example, I'd already added some log P, solubility, polar surface area, and molecular volume calculations for these chemicals. But if you wanted to add some additional properties to this table, you can go to the chemistry button and choose calculate properties. And this will open up this window, and it has a number of different properties that you can calculate. You can calculate polar surface area, molecular area, volume, some counts of number of fragments, number of rotatable bonds. So we can add some, just for this example, we can add number of rotatable bonds, number of hydrogen bond acceptors and donors here. And also inbuilt are some models for things like predictions of Hurg interaction, and whether the compound is what's called a PAN inhibitor, a pain compound, based on the work by Jeffrey Beal. You can read the paper here. It'll predict whether it's a PAN assay interference compound. And there's some other predictions we have as well, such as toxicity. It will display a chemical alert for certain groups, or whether the chemical has a potential to be a covalently linked or cleaved in a prodrug. So there's other chemicals here. So basically, you can select the properties. If you're doing this live, then be careful, because some of these take a while to run. They're larger scale predictions, and we have predictions for over. We have other models for over 1,200 different targets. That's in a separate product called MoleScreen, and that will give you a prediction of binding to other targets for polypharmacology and things like that. I had some quite a few questions. I need to go through them, but I'll probably get to some of them at the end of this example. So for this example, we have a number of rotatable bonds, number of hydrogen bond donors, acceptors. We just go OK, and then they're immediately placed into the chemical table here. So we have these extra columns, number of hydrogen bond acceptors and donors. Next week we're going to do a lot about the plotting options, but you can make a plot here. So just to show you, we can click on the plotting button here, and it opens this window, and we can plot, for example, molecular weight against log P. Okay, and it has different dimensions, so we can add another dimension, right click, and choose make the point size based on the area, molecular area, and we can color by here. You click, so it's going to, as long as there's a column, you can choose it. You can color by solubility and apply, and we have this fully interactive spreadsheet. We can make selections here, and so this is fully interactive. So if you make a selection here, the selection is propagated to the spreadsheet. So we can see that the blue ones are the ones that have been selected. Okay. And then we have so there's we'll cover some other options in the plots in 2 weeks' time when we're doing searching and other options. So we can also, if you want to export this table, so you can export it to Excel if you wanted to share it. You can right-click and choose export to Excel. It takes a little time to convert, so I won't do it live, but you just click here. Or you can save as, and save it as another SDF file to read into another software if you need to, or comma separated value file format, and you can do it that way. So you can also export I was going to make a smaller, I can do it with this one. We can export this, you can export the chemical table to HTML, so you just click here, give the table, the HTML page a name, and you can choose the options here, go OK, and then now you can see it in a minute here as a it's in an HTML format, so you can save it and share it. So another way to share this data with your colleagues would be you can, so it's going to undo some, would be to save it as a project file. So you can file, save project as, and it will, you can save it as an ICB format, and then your colleagues can open this, exactly what you see here, in the free ICM browser. So they can have it on their laptop, and it's a free environment, and you can share this data with them. So moving on to other things, we're going to have we're exporting them, and we can do other things inside the table as well. So we had some questions about how to manipulate the data in the table, and so you can make selections. So if we have some, if you have a chemical that you like, you can, or you're interested in, you can use the left click button to make a selection. You can hold Control to make a non-contiguous selection, and then you can tag them by right-clicking, and there's an option called Mark Selected Rows, and you can color them as one, for example, red. And so if you're interested in these chemicals, then you can go back and use that selection to make selections. So we've marked them, but then you can select the marked rows like this. And I want to select the ones that I've marked red. Now you can see they're colored dark blue, and we can then export those to, we can append them to a new table by right-clicking and choosing New, and give the table a name. So you make another table, another spreadsheet, and you have them here. You can also copy and paste in a similar way. So if you wanted to just paste, if you had a selection, so you can select the column that you want to keep, the name, for example, and the mole, and I just want to select these three again. And if I go right click and say copy, it's telling me that it's going to append it's going to make a new table with those three columns and those three chemicals that I selected. So we have just the molecular weight, name here. We can add additional data to our database by right-clicking on the row number and say insert chemical, an empty row after or before, and that loads a new row. You can see we have ND for no data for these predictions, but you'll see if we double click here, we can add a new sketch. Just going to add something basic. And if we close, we submit the changes to the table, and then we can recalculate the dependent columns, and it will calculate the molecular weight for those and everything that it will recalculate that value. When I added this, when you do chemistry, calculate properties, you need to store the formula in here, and it will recalculate those values for you. So this is the COX-2. We have the COX-2. You can also use the chemistry menu option to compare two tables. So I'm going to delete this one. We don't need this one. Don't need this one. So we have two tables. Remember, the one Chemical Search and a small database that we made by sketching and drawing. So we can compare these two and see if we can find these molecules in here. We can go to Chemistry and choose Compare Two Sets. And we can say I want to match COX-2, see if I can find these COX-2 inhibitors that I drew in the Chemical data. So the first table is the COX-2, second table is this one, the Chemical one, and I want to find them. I want to find exact matches. Well, next week we're going to do some chemical searching, so you can use chemical similarity based on a Tanimoto distance, but in this example I'm just going to do exact. Go OK, and it's done the search, and the other way around, sorry. Go chemistry. Let's do. Now you see that now we have some selected rows in the chemical spreadsheet where it's found the drug that we were looking for. It should. We have if you hover over here, you can see at the bottom it says 3 selected records. There are some selection tools that make it easier to find those 3 selected records. We can right-click and go to Row Selection and just choose Show Only Selected Records, and then we can see that the drugs in our table that we searched are also in Chemical here. So we just need to right-click and say go back to the row selection and just select everything and show array. Okay. So you can also filter by certain options. By you go to, if you want, by the data in your chemical spreadsheet, you go to the filter tab here, and it's going to display. So on the side of every table, there's a tab called Filter. So you can say, I just want to see the molecules in my table. You can search them, or you can say by molecular weight, for example here. I just want to see the chemicals that are between 300 and 500 molecular weight. You can see the plot changed, and we have just between 300 and 500. And then this table has shrunk as well. It's displaying 4,381 chemicals from a table of 5,714. And we know that this this column has been sorted because we have this symbol here next to the name of the column. So we can also add another filter if you wanted to. For example, log P. We can say we just want those chemicals which have a predicted log P between 0 and 6, for example. And we have another plot here, and now we can see that the log P column will have a sort function here. So you can use these options. There's chemical search, as I mentioned before, that you can use, which we'll cover next week. Okay, so we're getting near to the end of the demonstration, but I just wanted to sort of give an example of a scenario that comes up quite often in labs that we work with. So in some cases, people have all their data in an Excel file or in comma separated value format. So for example, I've got an example here. You may be presented with a data like this. It's going to open in a second. There you go. So your colleagues provide you with smile string, the name of the compound, and an ID from your lab, ID number. You may want to convert this smile string in this big table into the 2D sketch. So to do that, we go to Chemistry, Convert, and then there's the option Smiles. This could be an Inchi string to 2D. Just click. It asks us the table name, which is these are thyroid hormone receptor inhibitors, and the Smiles column is here. Has this Smiles column contains the Smiles string. Just go OK, and that immediately, you click OK, it will convert to 2D. And another scenario is that your colleague or colleagues have maybe tested these structures, these chemicals in an assay, and they give to you a table from Excel, for example, that looks like this. So this is your table, and your colleague gives you this chemical spreadsheet in Excel format, and you want to match. You want to be able to put this table only contains the ID number and the PKD from their experimental work. So you want to be able to merge these two tables. So to do that, you would need to go to Tools, and there's a button called Table, and then you get the option Add External Column. And so the target table is the place you want to put all the data into, and I want to put it into this 2D only Smiles, and I want to match by column ID. I want to match the ID numbers, and I want to take the activity data from the other table called thyroid hormone receptor activity inhibitors activity, and match them and go OK. And then you can see that the PKD value has been transferred from this table to this one, and then you can use that and save it as an Excel file or what have you. Another common scenario is that you have you're trying to register compounds or have a so you keep adding, as we were doing at the beginning, you keep adding compounds to your database. So you can create an empty chemical table by going to Chemistry, create empty chemical table, and then you give the chemical table a name. It asks you, do you want to add an ID column? And you add your ID prefix, so you could say Molsoft or some free code that you use for your company. And by default, we're just going to add one empty row. Go next. And then it's asking you, every time you add something to this chemical spreadsheet, what do you want it to calculate on the fly? And I'll just say I want molecular weight, log P, go OK. And then this is our spreadsheet, and then you can add, just double click in the mole column and you can add chemicals to it. And then you can add rows as well here. You can also keep a plot as well on the side. So it's a way to just open a clean, empty chemical spreadsheet. And then finally, I just wanted to show that with the larger spreadsheets, you can also add other data as well as properties. You can also do other calculations. So if you wanted to add a column here, you can right-click and say Insert, Calculate Insert Column. Then you can add a variety of different functions. So you can add columns together, arithmetic, and there's also you can add new strings, a new real array here. You can also add images, so you can say I want a new column with images. Okay, function new. And then you can just right click and say set image from file, and you can go here and choose an image, and it'll add the image to your spreadsheet here as well. Okay, so they're images, so you can save this or export it to Excel. Okay. I just wanted to thank you very much for your questions, which I'll get to in a second. And if you have any questions after the webinar, please feel free to email or call. And if you haven't received the email yet with the instructions on how to download the software, I'll get to that later today. And please join us for the upcoming webinars on chemical data analysis and searching, chemical library enumeration, which will include things like enumerating a library by Marcouche R group, enumeration by reaction, and filtering of the enumeration, as well as multi-parameter optimization. And then the final webinar will be undertaken by Eugene Rausch, who is our principal developer here at MolSoft, and he'll be looking at R group decomposition by a scaffold, 2D SAR analysis, matched pair analysis, and 2D bioisosteres as well. Okay, so I have some questions that I didn't get to at all during the webinar. I'll try and address them now, but thank you very much for your attention. Okay, so I had a question of how to copy and paste columns. So one way to copy and paste is to, you can actually right click and say copy column, and then you paste it here. Or if you're going from one table to another, it's probably best to use the tools I showed earlier. Go to tools, table, and then append rows from a different column here. That's one way to do it. I had a question about how to move to move columns around. You can do that quite straightforward. So yeah, you're right. This would be better. You can move the compound, a column, basically just by right-clicking on it and choose Move Column. Right-click on the column header, choose Move. You can say you want it to be after the mole, for example. This will move log the solubility prediction here. Okay, and you can move it around. I had a question on how to freeze a row. So yeah, a freeze row is sometimes useful. If there's a chemical you're particularly interested in and you want to compare it with the others, you can select the row like this. Freeze columns as well. I'll show that in a minute. So you right click and you can choose freeze row. So that puts that row at the top. And then the rest of the so I just need to close. Yeah, so the rest of the table is scrollable at the bottom, and this freezes this row here. Okay, yeah, and to unfreeze it, you right-click and choose Unfreeze. Freeze a column, you can do the same thing. Just right-click on the column and choose Freeze somewhere along. I think you have to select it. You should, freeze column here. Okay, so I had a question about toxicity. We do have inbuilt into ICM some predictions of toxicity. If you go to the chemistry, calculate properties, you'll notice at the bottom we have what is called a tox score, and that will give you a prediction of basically it's a collection of chemical alerts provided by chemical suppliers, and so if you get a value of greater than 1, it indicates that the substructure may be toxic, and you just go chemistry and it'll produce that tox score, and it'll give you a chemical alert for each issue, and you can see it yourself. You can also run the pains molecule prediction as well. Okay, so that's toxicity. Is it possible? Yeah, you can. Next week we're going to cover a question about plots inside columns. You can add, you can have inbuilt plots into a cell, which I'll show in a couple of weeks' time, and it will export. I need to check whether it export it to Excel correctly. I haven't tried it myself, but I guess it will, because it'll be like an image in the column. But I'll check on that. Had a question about marking rows. So we showed. I was going to delete this column. So you can mark a row by. You can actually use the keyboard, so you can select a row that you like and just use 1, and that will color it red. 2, and that will color it yellow. Or you can right-click and choose Mark Selected Rows, and it will do it that way. I'm not sure if we can go beyond 5 options. Probably not, but that would be useful. Yeah. The question was how to mark more than, because if you right click here you can see that we have these marks here, only 5 options as how to mark more than 5. Can do it, show it there. Had a question on how to hide rows and columns. Yeah, so you can hide a row by right clicking on the row and selecting them, and then choose hide. And the same in the column. If you select a column, you can hide, right click and choose hide columns here. There's some other questions that are a bit tricky to address immediately, so I'll try and get back to you by email on those. I had one. Please demo copying and pasting selected table cells when it's not the whole column that is selected. So you just want to, if you just want to select a subset of a column, you select the rows that you want to include, and then the columns here. So here we'll have a table of 3 by 3. We'll have 3 columns, 3 rows. Right click and you choose append to table new, and that will just give you those columns that you chose and the rows that you chose. That cross section. Maybe I should do it in a white space. So I made a selection here, and then a selection here, and then right click and say copy to table new. Had a question about the buttons on the right hand side. The first one, this one just opens the extra panel, so it gives you the filtering options. It will have the histograms and plots, which we'll cover in a couple of weeks' time here. That opens the extra panels. And you can also use this panel. Yeah, the one below is editing, so that if you click on the edit button, then it immediately makes the table fully editable. So if you double click on a cell, you can then edit the values here. Right, so. I had a question that they noticed some duplicates in this table. You can identify duplicate or chemicals that are, to select duplicate chemicals. I'm not sure if there are any in here. There might be. If you go to chemistry and select duplicates, that will go through your chemical spreadsheet and identify chemicals that are similar, have the same substructure. And you just go OK. Not sure. Yeah, we didn't find any in this spreadsheet, but might be. So go chemistry, select duplicates. Here. What happens if you have duplicate rows in one table when you merge data? That's a good question. Yeah, so if you go to File and we're going to go to Tools, Table, Append Rows, yeah, I need to find out the answer to that question. I need to test it. So the question was, if you have multiple rows in the table, how would it decide which ones to choose to merge? And I'll find the answer to that outside the webinar. The other question was, how do you add the ID numbers? So yeah, one way was to go to create, well, you can create a clean chemical table. If you wanted to add ID numbers to this table, for example, you'd go to the Insert Column option, calculate insert column, and go function new ID, and you give the ID a name, so, and go OK. And that adds incrementally the ID number here. Okay. I had a question about, can you directly import from Microsoft Access format? Not probably directly from the actual Access format, but if you can find some other way of saving that data. So basically we can read STF, we can read comma separated value, Excel format, but I'd have to look into that particular example. If you're going to directly take it from the Access, I need to look into that and I'll get back to you. Energy minimization of drawn chemical structures, is it possible? Okay, yeah, if you have if you sketch in ICM-Chemist, we have this option to convert to 3D. So we have here Vioxx, so we can convert the Vioxx molecule to, it's Arcox, yeah. Go OK, and that will convert that chemical to 3D. In ICM-Chemist Pro, there are options to do a full minimization, full optimization in the molecular force field, and you'd get a stack of the most energetically favorable conformations for that ligand. But the ICM-Chemist environment is more designed for 2D work with chemical spreadsheets. So there's quite a few questions. Getting close to 10 o'clock, but I'll try and get back to some of those at another time, I think. A question about making these selections again. So selections are just using single click control as non-contiguous selection. It's the same with the columns as well. You can use control to, or you can use shift to select a range. And another question: how do we change the width of the rows? If you change the width of the rows, you can, if you hold Control, you can also change the width of these rows by dragging and holding Control, and they'll be adjusted at the same time. Okay, so I think I will get back to some of the other questions via email. I'd like to thank you very much for your time, and I hope you get the software up and running so you can play around with it. If you have any questions after or now, you can always email me or call. Thank you very much for your time.